Imagine yourself adrift in a black ocean. Above, below, all around, an endless expanse of inky black. No stars twinkle in the distance. No familiar constellations light your way. There's no comforting glow of the moon, no distant planets to stir your imagination. There is only the silent, oppressive presence of absolute nothingness. This might sound like a scene from a chilling science fiction film, a fictional horror we can experience from a safe distance. But what if this terrifying vision reflects our reality more accurately than we ever dared to imagine? Scientists are now uncovering a truth about our universe that is both awe-inspiring and profoundly unsettling. The vast expanse of space surrounding our galaxy, the Milky Way, is not filled with the celestial wonders we once envisioned. Instead, it is a region so unimaginably vast, so eerily empty, and so shrouded in mystery that it's forcing us to completely reassess our place in the cosmos. This is not just about empty pockets between stars, the kind we learn about in astronomy class. This is about something far grander, far more profound, and far more unsettling. It is the story of cosmic voids, terrifyingly real abysses stretching across unimaginable distances, swallowing light, time, and matter into their silent depths. These voids, we're learning, are not mere anomalies. They are not insignificant blips on the cosmic radar. They are, in fact, the defining characteristic of the universe, a truth that has the power to reshape our understanding of existence itself. Join us now on a journey into the heart of these cosmic voids, where the very fabric of space and time seems to unravel, and where the familiar laws of physics begin to whisper unsettling new truths. For centuries, humanity clung to the comforting notion that we held a special place in the universe. We looked up at the night sky, ablaze with stars, and felt a sense of connection, of belonging. Earth, our pale blue dot, was the center of our universe, literally and figuratively, a place of unique importance in the grand cosmic scheme. But as our scientific understanding progressed, a humbling truth began to emerge. Telescopes grew more powerful, peering deeper into the cosmos, and revealing a universe far larger, far stranger, and far emptier than we had ever dared to imagine. Our cosmic neighborhood, once thought to be bustling with galaxies, stars, and planetary systems, revealed itself to be a cosmic desert, sparsely populated and dominated by a chilling emptiness. This wasn't just a matter of empty space between stars, the kind we could explain away as vast distances separating celestial objects. This was different. This was emptiness on a scale that defied comprehension. It was the discovery of enormous voids between galaxies, cosmic deserts stretching across the universe, their vastness challenging our very understanding of existence. These voids were not merely empty, they seemed to actively swallow light, time, and matter, drawing them into an abyss of pure nothingness. And the most unsettling part of all, mounting evidence suggests that our entire galactic neighborhood, the Milky Way, our solar system, even Earth itself, might be precariously perched near the very heart of one of these cosmic voids. This revelation, that we might exist inside a cosmic void, is not just an astronomical curiosity. It's a discovery with profound implications, shaking the very foundations of our understanding of the universe and our place within it. To grasp the true scale of this cosmic emptiness, we need to embark on a journey that will take us far beyond the familiar confines of our solar system, beyond the swirling arms of the Milky Way, and even beyond the clusters of galaxies that lie scattered throughout the cosmos. At these mind-boggling distances, galaxies, those majestic islands of stars and gas, appear as mere specks of dust, like faint embers scattered across a vast, dark canvas. But even in their diminished state, they reveal a pattern, a structure that hints at the underlying forces shaping the universe. These galaxies, we've discovered, are not randomly scattered throughout the cosmos. Instead, they cluster together, drawn by the irresistible pull of gravity, forming colossal clusters connected by luminous filaments. These filaments, composed of stars, gas, and dark matter, weave a complex tapestry across the universe, forming the largest known structure in existence, the cosmic web. And it is within the vast expanse of this cosmic web, between these luminous threads of matter and energy, that we find the voids. These voids are not merely empty spaces. They are regions where the universe, still echoing with the energy of the Big Bang, took a different path, where matter, instead of clumping together to form stars and galaxies, was stretched thin, leaving behind vast, desolate regions of near-perfect emptiness. The existence of these cosmic voids is not just a theoretical concept, a mathematical quirk predicted by our models of the universe. It's a reality confirmed by countless observations, a reality that is forcing us to confront the unsettling fact that our universe is not a place of uniform distribution, but rather a vast, intricate tapestry of matter and emptiness, of light and shadow, of existence and nothingness. In fact, these voids, far from being rare occurrences, dominate the cosmic landscape. Current estimates suggest that over 80% of the universe's volume is made up of these vast, near-empty regions, their presence dwarfing the luminous galaxies and clusters we once believed to be the dominant feature of the cosmos. While galaxies sparkle along the intricate filaments of the cosmic web, like jewels scattered across a celestial tapestry, the voids themselves remain stubbornly empty, their darkness resisting even the prying eyes of our most powerful telescopes. Within these vast expanses, there exist only a smattering of faint, dwarf galaxies, their dim light struggling to pierce the oppressive darkness. Thin, ethereal clouds of gas drift through these desolate regions, remnants of a time when the universe was young and full of promise, but even these are few and far between. For the most part, the voids remain realms of vast, relentless emptiness, their silence broken only by the faint whisper of the cosmic microwave background radiation, the fading echo of the Big Bang. And it's within one such void, a region of cosmic emptiness known as the local void or the KBC void, that our own Milky Way galaxy, along with its billions of stars and countless planets, appears to reside. The realization that our galaxy, our cosmic home, might be nestled within one of these colossal voids is both awe-inspiring and, honestly, profoundly unsettling. It's as if we've been living on an island paradise, blissfully unaware of the vast, uncharted ocean that surrounds us. The local void, as it's known, is not just large. It's colossal even by cosmic standards, stretching over 2 billion light-years across, a stark reminder of the universe's penchant for both grandeur and emptiness. To put that into perspective, light from galaxies on the far side of the local void takes over 2 billion years to reach us, meaning we see them as they were when life on Earth was just beginning to emerge from the primordial soup. This discovery of our cosmic isolation, our existence within a region of profound emptiness, has thrown a wrench into some of our most cherished cosmological models. The cosmological principle, a cornerstone of modern cosmology, suggests that the universe should be relatively uniform on large scales. In other words, zoom out far enough, and the universe should look roughly the same, regardless of where you are. Yet, here we are, apparently nestled within one of the most significant cosmic anomalies ever discovered, a region so devoid of matter that it challenges our very understanding of how the universe is structured. The local void, however, is not merely a vast, empty expanse. It's a dynamic region shaped by the interplay of gravity, dark energy, and the echoes of the Big Bang. Galaxies within the local void, instead of being drawn together by gravity, as we might expect, are actually moving away from each other, seemingly repelled by the void itself. This outward motion, this galactic exodus, is a testament to the subtle but relentless power of the void. With so little matter within its boundaries, the gravitational pull of the local void is significantly weaker than the surrounding regions, creating a sort of cosmic pressure gradient. Galaxies, feeling this imbalance, naturally drift towards areas of higher density, away from the emptiness of the void. Think of it like air rushing out of a punctured tire. The air molecules, driven by the pressure difference, flow from an area of high pressure, inside the tire, to an area of low pressure, the outside air. Similarly, galaxies within the void drift outwards, their movement guided by the invisible hand of gravity, seeking refuge in the denser regions of the cosmic web. But the local void is not content to simply sit there, a passive region of emptiness. Like all voids, it's growing, expanding outwards as the universe ages and dark energy continues its relentless push. This expansion, however, is not a violent explosion, but rather a slow, steady stretching of the fabric of space-time itself. As the void grows, it pushes galaxies further apart, isolating them from their neighbors, turning the cosmic web into a tapestry with increasingly distant and disconnected threads. This expansion is not just a matter of academic intrigue, it has profound implications for our understanding of the universe and our place within it. The local void's influence extends far beyond its immediate boundaries, subtly affecting our measurements of the cosmos and potentially skewing our perception of the universe's expansion rate. One of the most perplexing aspects of the local void is not just its emptiness, but also the sheer scale of that emptiness. It's not just that there are fewer galaxies within the void than expected, it's that there are far, far fewer. Astronomers, peering into the depths of the local void, have found a staggering deficit of galaxies, a missing population that should be there, based on our understanding of the early universe and the processes of galaxy formation. This missing matter, this galactic ghost town, is one of the biggest mysteries facing modern cosmology. Where did these galaxies go? Did they never form in the first place, their birth stifled by the void's unusual environment? Or were they somehow removed, their stars and gas stripped away by some unknown cosmic mechanism, leaving behind only a vast empty expanse? The answers to these questions remain elusive, but each possibility carries with it profound implications for our understanding of the universe. If galaxies never formed within the void, it suggests that our current models of galaxy formation, based on the clumping of dark matter and the slow accumulation of gas, might be incomplete, missing crucial factors that influence galactic birth in these unusual environments. On the other hand, if galaxies were somehow removed from the void, it hints at the existence of powerful, yet unknown, astrophysical processes capable of dismantling entire galaxies, scattering their stars and gas across unimaginable distances. Such processes could reshape our understanding of galactic evolution, painting a picture of a cosmos where galaxies are not just born and evolve, but can also be torn apart, their constituent parts recycled into the intergalactic medium. While the exact mechanisms responsible for the local void's formation and evolution remain shrouded in mystery, one thing is becoming increasingly clear. Dark energy, that enigmatic force driving the accelerating expansion of the universe, plays a crucial role in shaping these vast realms of emptiness. In the cosmic tug-of-war between gravity, which tries to pull matter together, and dark energy, which pushes it apart, voids represent the ultimate victory of the latter. Within these vast expanses, devoid of the gravitational anchors of galaxy clusters and superclusters, dark energy reigns supreme, its influence unchecked by the clumping power of matter. As the universe expands, the influence of dark energy grows stronger, stretching the fabric of space-time, pushing galaxies further apart, and driving the growth of cosmic voids. This makes voids like our local void not just windows into the distribution of matter in the universe, but also powerful laboratories for studying dark energy itself. By observing how galaxies move within voids, how they cluster, or rather how they don't cluster, and how the voids themselves evolve over time, cosmologists can glean crucial insights into the properties and behavior of this mysterious force. Understanding dark energy is one of the most pressing challenges facing modern cosmology. It's a force we can't see, touch, or directly detect, yet its influence dominates the evolution of the universe on the grandest scales. By studying voids, these vast realms of emptiness where dark energy's grip is most apparent, we might finally begin to unravel the secrets of this enigmatic force and its implications for the ultimate fate of the cosmos. However, beyond the realm of conventional astrophysics and cosmology, the existence of cosmic voids like our local void has also sparked some truly mind-bending speculation. Some theorists have proposed that the emptiness we observe in these voids might not be entirely natural, that it could in fact be the result of the actions of advanced extraterrestrial civilizations. This idea, while seemingly far-fetched, is rooted in the concept of Kardashev Type 3 civilizations, hypothetical civilizations that have reached a level of technological sophistication where they can harness the energy output of entire galaxies. Such civilizations, it's speculated, might possess the ability to manipulate matter and energy on unimaginable scales, potentially even altering the structure of space-time itself. Could it be that the local void, with its perplexing lack of galaxies and its unusual gravitational dynamics, is not a naturally occurring phenomenon, but rather an engineered structure, a cosmic monument left behind by a long-vanished civilization? Perhaps these hypothetical beings, in their quest for resources, or in their pursuit of some grand cosmic engineering project, rearrange the matter in their vicinity, creating the void we observe today. Or even more tantalizing, perhaps they discovered a way to manipulate dark energy itself, using its repulsive force to sculpt the universe, pushing matter aside to create vast, empty spaces for their own purposes. While such ideas remain firmly in the realm of speculation, they highlight the profound philosophical and existential questions raised by the existence of cosmic voids. The discovery of cosmic voids didn't happen overnight. It wasn't a sudden revelation that shook the foundations of astronomy. Instead, it was a gradual unveiling, a slow dawning of realization that emerged from decades of meticulous observations, painstaking data analysis, and a willingness to question long-held assumptions about the universe's structure. For centuries, astronomers operated under the assumption that the universe, on the grandest scales, was relatively uniform. Yes, there were stars and planets, nebulae and galaxies, but these were seen as variations on a theme, like ripples on the surface of a vast cosmic pond. The discovery of galaxies themselves, those island universes scattered throughout the cosmos, challenged this notion to some extent, but the underlying assumption remained. The universe was a relatively crowded place, filled with luminous matter. However, as our telescopes grew larger and more sophisticated, as we began to map the universe in 3 dimensions, a different picture began to emerge. Astronomers, charting the positions and movements of galaxies, noticed something peculiar, something that didn't quite fit with the prevailing cosmological models. Galaxies, it seemed, were not distributed evenly throughout space. Instead, they clustered together, forming vast filaments and walls surrounding seemingly empty regions, like towns huddled around oases in a vast desert. These underdense regions, initially dismissed as statistical anomalies or gaps in our observations, gradually revealed themselves to be something far more profound: the cosmic voids. The study of cosmic voids is, honestly, a relatively young field, driven by technological advancements that have allowed us to peer deeper into the universe and map its structure with, well, unprecedented detail. The key to this mapping lies in large-scale galaxy surveys, which are these ambitious projects aiming to chart the positions and movements of millions of galaxies across the cosmos. These surveys, such as the Sloan Digital Sky Survey and the 2-degree Field Galaxy Redshift Survey, rely on a combination of powerful telescopes, sensitive detectors, and, some pretty sophisticated software to capture and analyze the faint light from distant galaxies. By measuring the redshift of this light, a stretching caused by the expansion of the universe, astronomers can determine a galaxy's distance from Earth. With enough distance measurements, a 3-dimensional map of the universe begins to emerge, revealing the intricate cosmic web of galaxy clusters, filaments, and, of course, the voids that lie between them. But mapping the voids isn't just about pinpointing the location of galaxies, it's also about understanding the properties of the voids themselves. Astronomers are interested in their size, shape, distribution, and how these properties vary over time. They're also keen to understand the conditions within voids, the density of matter or lack thereof, the temperature of the gas that permeates these regions, and the strength of the gravitational fields that govern the movement of any matter that dares to venture within their boundaries. Mapping the voids, however, presents some unique challenges. By their very nature, voids are regions of extremely low matter density, meaning they emit very little light of their own. This makes them incredibly difficult to observe directly, especially at large distances. To overcome this challenge, astronomers have turned to a variety of ingenious techniques, exploiting the subtle ways in which voids interact with light and matter. One such technique is gravitational lensing, a phenomenon predicted by Einstein's theory of general relativity. Massive objects like galaxies and clusters of galaxies warp the fabric of space-time around them, creating a sort of cosmic lens that bends the path of light passing by. When light from a distant object, like a galaxy, passes through or near a void, the absence of mass within the void alters the lensing effect, creating subtle distortions in the lensed images. By carefully analyzing these distortions, astronomers can infer the presence and properties of the void, even though the void itself remains invisible. Another technique involves studying the movement of galaxies that lie near the edges of voids. As mentioned earlier, galaxies within voids tend to move away from each other, driven outwards by the weaker gravitational pull of the void compared to the surrounding regions. By measuring the velocities of these galaxies, their speed and direction, astronomers can map out the gravitational field of the void, much like cartographers charting the contours of a valley by observing the flow of water. These techniques, along with others still under development, are providing us with an increasingly detailed picture of the void, revealing their secrets and shedding light on their role in the evolution of the universe. While all cosmic voids share certain characteristics, they're all regions of below-average matter density, and they all play a role in the large-scale structure of the universe. They're not all created equal. Voids come in a range of sizes, from relatively small voids, spanning a few million light-years across, to colossal behemoths that dwarf our local void, stretching hundreds of millions of light-years across the cosmos. Our local void, as we've discussed, is a prime example of a smaller void, albeit one with profound implications for our understanding of the universe. Its relative proximity, coupled with its unusual properties, makes it an ideal laboratory for studying the dynamics of voids and their impact on galactic evolution. However, in the grand scheme of cosmic voids, our local void is but a dwarfed by the sheer scale and emptiness of voids like the Boots void, a cosmic behemoth that puts our local void to shame. Located approximately 700 million light-years away in the constellation of Bootes, the Boots void is a staggering 330 million light-years across. To put that into perspective, if our Milky Way galaxy were a grain of sand, the Bootes void would be the size of the Earth. It's so large, in fact, that it's often referred to as a supervoid, a testament to its status as one of the largest known structures in the universe. The Bootes void, unlike our relatively crowded local void, is a region of truly mind-boggling emptiness. While a typical region of space that size would contain thousands of galaxies, the Bootes void contains only a few dozen, making it one of the emptiest known regions in the observable universe. To call it a cosmic desert would be an understatement. The discovery of the Bootes void in 1981 sent shockwaves through the astronomical community. Its sheer scale and emptiness challenged the prevailing cosmological models, which struggled to explain how such a vast region could be so devoid of matter. Some theorists speculated that the Bootes void might be a region where the universe's expansion had somehow run away, creating a zone of accelerated expansion that prevented galaxies from forming. Others proposed that the void might be the result of a collision between multiple smaller voids, their merger creating a cosmic behemoth. Still, others pointed to the potential role of exotic physics, suggesting that the void might harbor strange forms of dark matter or energy that suppress galaxy formation. Despite decades of study, the true nature and origin of the Bootes void remains shrouded in mystery. It stands as a stark reminder of how much we still don't know about the universe, a cosmic enigma that continues to challenge our understanding of the cosmos and our place within it. The Bootes void, with its haunting emptiness and its enigmatic origins, serves as a powerful symbol of the universe's capacity for both grandeur and desolation. The existence of cosmic voids, those vast expanses of near-perfect emptiness that punctuate the cosmic web, might seem, well, a bit counterintuitive. After all, we tend to think of the universe as a place teeming with stars, galaxies, and planets, a cosmic tapestry woven with luminous threads of matter and energy. Yet these voids are not merely gaps in the cosmic fabric. They are integral parts of the universe's structure, their origins intertwined with the very moments of creation itself. To understand how voids formed, we need to rewind the cosmic clock, Journey back to a time when the universe was young, hot, and incredibly dense, a time just fractions of a second after the Big Bang. In those earliest moments, the universe was not the structured, differentiated entity we observe today. Instead, it existed as a hot, dense soup of elementary particles, a seething cauldron of energy where matter and radiation were inextricably intertwined. However, within this seemingly uniform primordial soup, the seeds of cosmic structure were already sown. Tiny quantum fluctuations, inherent to the nature of space-time itself, created minute variations in density, regions where matter was ever so slightly more or less concentrated than average. These fluctuations, though incredibly small, just 1 part in 100,000, would prove to be the catalysts for the formation of all the structures we observe in the universe today, from the smallest stars to the largest galaxy clusters, and of course, the vast cosmic voids. In the early universe, gravity, the weakest of the fundamental forces but relentless in its influence, played a pivotal role in amplifying these primordial density fluctuations. Regions where matter was slightly denser exerted a slightly stronger gravitational pull on their surroundings, drawing in more matter, growing denser still. Over millions of years, this gravitational tug-of-war continued, the denser regions pulling in more matter, becoming the seeds of galaxies and galaxy clusters, while the less dense regions, starved of matter, grew emptier, eventually evolving into the cosmic voids we observe today. Imagine a cosmic game of tug-of-war, not with ropes and teams, but with vast clouds of primordial gas and the invisible hand of gravity pulling on them. The denser regions, with their stronger gravitational pull, slowly but surely win the game, reeling in more and more matter, growing larger and denser, eventually collapsing under their own weight to form the stars and galaxies that light up the cosmos. However, this victory comes at a cost. As matter flows towards these gravitational wells, the regions between them are left increasingly empty. These underdense regions, the losers of the cosmic tug-of-war, expand outwards, becoming the vast, desolate expanses we now call cosmic voids. While gravity played a crucial role in the early formation of voids, it's another, more enigmatic force that governs their evolution on the grandest scales: dark energy. This mysterious entity, thought to permeate all of space, exerts a negative pressure, a repulsive force that counteracts gravity's pull and drives the accelerating expansion of the universe. Within the vast emptiness of cosmic voids, where matter is scarce and its gravitational influence weak, dark energy reigns supreme. Here, its repulsive force is most apparent, pushing the boundaries of the voids outwards, driving galaxies further apart and accelerating the expansion of these cosmic deserts. Think of dark energy as a cosmic anti-gravity, a force that pushes things apart rather than pulling them together. While gravity patiently sculpted the cosmic web, drawing matter together to form stars, galaxies, and clusters, dark energy works behind the scenes, steadily stretching the fabric of space-time, pushing these structures further apart and enlarging the voids that lie between them. This ongoing expansion, driven by dark energy, has profound implications for the future of the cosmos. As the universe continues to expand, the cosmic web will become increasingly stretched and tenuous, its filaments thinning, its walls dissolving, and its voids growing larger and more dominant. In the distant future, the universe might resemble a vast cosmic sea of emptiness, dotted with the occasional island universe, separated by unimaginable gulfs of nothingness. While the interplay of gravity and dark energy explains the large-scale structure of voids, some scientists believe that more exotic physics might be at play, particularly in the very early universe. Quantum mechanics, the theory that governs the behavior of matter and energy at the smallest scales, introduces an element of randomness and uncertainty into the equation. In the first fleeting fractions of a second after the Big Bang, during a period of rapid expansion known as cosmic inflation, quantum fluctuations might have been amplified to enormous scales, creating regions of significantly different density, even within the otherwise uniform primordial soup. Imagine the early universe as a vast quantum foam, a sea of virtual particles popping in and out of existence. their fleeting lives governed by the laws of probability and uncertainty. During inflation, this quantum foam was stretched to unimaginable sizes. Those tiny quantum fluctuations, normally confined to the subatomic realm, were blown up to cosmic proportions, leaving their imprint on the fabric of space-time itself. These amplified quantum fluctuations, frozen in place as the universe expanded, could have created regions of higher or lower density, acting as seeds for the formation of galaxy clusters and voids, respectively. Some models suggest that these quantum fluctuations, amplified by inflation, could explain the existence of extremely large voids, like the Bootes void, which are difficult to account for using only the standard model of cosmology. While the scientific community generally accepts that the origins of cosmic voids lie in the interplay of gravity, dark energy, and the conditions of the early universe, some intriguing, albeit speculative ideas suggest that these vast expanses of emptiness might be more than just natural phenomena. Could they, some theorists propose, be the remnants of ancient, advanced civilizations, cosmic engineering projects, on a scale that dwarfs our current comprehension? The idea that cosmic voids could be artificial structures is often linked to the concept of Kardashev Type 3 civilizations, hypothetical civilizations that have reached a level of technological advancement that allows them to harness the energy output of entire galaxies. Such civilizations, wielding energy on scales unimaginable to us, might possess the ability to manipulate matter and energy on cosmic scales, potentially even altering the structure of space-time itself. Could it be that the voids we observe, those vast regions seemingly devoid of matter and galaxies, are not natural formations, but rather the remnants of ancient engineering projects? Perhaps these hypothetical civilizations, in their quest for resources or in their pursuit of some grand cosmic design, intentionally manipulated the distribution of matter in the universe, pushing aside stars and galaxies, creating vast empty spaces for their own purposes. While such ideas remain firmly in the realm of speculation, the sheer scale and emptiness of cosmic voids, coupled with our limited understanding of the universe's earliest moments, leave room for wonder and imagination. The discovery of cosmic voids, vast expanses of near-perfect emptiness, has upended our understanding of the universe's structure. These voids challenge the cosmological principle, which claims the universe is uniform and looks the same everywhere. The existence of immense voids like the Bootes void suggests the cosmos is far more clumpy and uneven than we thought. This realization forces us to rethink how galaxies form and how the universe evolves on the largest scales. Cosmic voids may be influencing our measurements of the universe's expansion, especially the Hubble constant. The Hubble tension, a puzzling mismatch in expansion rate measurements, could be partly due to the unique gravitational effects of voids. With less matter, voids exert weaker gravity, subtly altering the motion of galaxies and potentially skewing our data. If we don't account for these effects, we might overestimate how fast the universe is expanding. Voids, then, aren't just empty. They could be distorting our view of the cosmos itself. Cosmic voids are natural laboratories for testing the laws of physics in extreme conditions. Their low density lets us probe gravity where it's never been directly tested, possibly revealing cracks in Einstein's theory. By tracking galaxies in and around voids, astronomers hope to confirm, or challenge, our understanding of gravity, dark matter, and dark energy. In these empty regions, the universe's deepest mysteries may finally come into focus. The vast emptiness of cosmic voids sparks profound existential questions about our place in the universe. Their scale dwarfs galaxies and highlights our isolation, challenging the idea that the cosmos is made for us. The immense distances and emptiness make the odds of encountering other life seem remote. This realization is both humbling and liberating, forcing us to see ourselves and our solitude in a new cosmic light. The prevalence of cosmic voids raises a haunting question. Is the universe fundamentally lonely? Instead of a bustling cosmos, we find isolated islands of matter separated by vast emptiness, making life seem rare. Some speculate that the universe isn't fine-tuned for life, but for solitude. Earth may be a true anomaly. Perhaps, though, the voids themselves hold clues to where life might cluster, challenging us to rethink what cosmic normal really means. Cosmic voids force us to confront a universe that is vast, empty, and indifferent to our existence. Our comforting narratives of cosmic significance are challenged by the reality of our tiny, isolated world. The emptiness strips away anthropocentrism, revealing a cosmos governed by its own laws, not our hopes. The result is a profound sense of isolation, yet also a clearer view of our true place in the universe. The emptiness of the voids can inspire a new perspective on our existence. In a universe dominated by nothingness, the emergence of life and consciousness is even more extraordinary. Our ability to question and explore is a testament to the universe's capacity for surprise and wonder. Embracing our cosmic context, we find meaning not in centrality, but in our curiosity and drive to understand. The voids evoke both fear and fascination, awe at their scale, terror at their emptiness. They challenge our need for comfort and connection, confronting us with the unknown. Yet in their emptiness, we find a canvas for imagination and a call to explore the ultimate mysteries. The voids beckon us to push the boundaries of understanding and venture into the cosmic wilderness. Cosmic voids haven't answered our biggest questions. They've multiplied them. But this isn't cause for despair. It's an invitation to explore, to push the limits of knowledge. We are explorers at heart, driven to understand even the emptiest corners of the universe. The quest to comprehend the voids is a testament to our enduring curiosity and spirit.
7, 6, 5, 4, 3, 2, 1.
You'll never have the sacred stone.
Oh, this you crazy mother.
The vastness of the voids teaches humility, reminding us we're not the universe's center. Yet, our ability to contemplate and explore these empty realms is a triumph of the human mind. The voids are not barriers, but invitations to learn, to grow, and to appreciate the rarity of existence. In the face of emptiness, we find not despair, but hope and a renewed sense of wonder. Throughout our journey into the heart of cosmic voids, we've encountered a paradox that really defines our very existence. It seems, well, counterintuitive, maybe even a bit unsettling, that the universe, a place teeming with the energy of billions upon billions of stars, could actually be primarily defined by emptiness. The cosmic voids, in their vastness and silence, challenge our intuitive understanding of reality. We are creatures drawn to light, to warmth, to the comforting presence of other living things. The void, in its stark and uncompromising emptiness, confronts us with the possibility of a universe far different from the one we instinctively imagine. Yet, this emptiness, this apparent absence of everything we hold dear, is not a sterile vacuum. It's a dynamic environment, shaped by the invisible hand of gravity, sculpted by the enigmatic force of dark energy, and potentially harboring the echoes of quantum processes that occurred in the universe's earliest moments. The voids remind us that the universe is not simply a stage upon which the drama of stars and galaxies unfolds. It's an active participant, shaping the distribution of matter, influencing the evolution of galaxies, and potentially playing a role in the very laws of physics that govern our existence. Within the context of these vast cosmic voids, the existence of life, of consciousness, of a species capable of contemplating its own fleeting existence against the backdrop of a billion-year-old universe, takes on a new and profound significance. We often speak of the vastness of space, the unimaginable distances between stars and galaxies, as if it were a barrier to our understanding, a reminder of our cosmic insignificance. But what if this vastness, this emptiness, is what makes our existence all the more remarkable? In a universe dominated by voids, where the emergence of life seems like an improbable accident, a chance encounter of energy and matter in the vast cosmic expanse, our presence here on this planet, our ability to question, explore, and dream becomes a defiant act of creation. We are, in a very real sense, the universe becoming aware of itself, a fleeting spark of consciousness ignited in the darkness, a testament to the universe's capacity for beauty, complexity, and wonder. Our existence, though transient, is a celebration of the universe's creative potential, a reminder that even in the face of overwhelming emptiness, something extraordinary can emerge. The cosmic voids, in their enigmatic silence, hold up a mirror to humanity, reflecting back to us not just the vastness of the universe, but also the depths of our own consciousness. They challenge us to confront our fears, our hopes, our beliefs about our place in the cosmic order. The void asks us to consider, what does it mean to exist in a universe where emptiness is the norm and life seems like a rare and precious anomaly? What responsibilities do we have as custodians of consciousness in a universe that seems indifferent to our fate? These questions have no easy answers. They are questions that philosophers, theologians, artists, and dreamers have grappled with for centuries. The discovery of cosmic voids simply amplifies these questions, adding a layer of, cosmic urgency to our search for meaning and purpose. But perhaps the answers we seek are not to be found in the stars or in the depths of cosmic voids. Perhaps they are to be found within ourselves, in the very act of questioning, exploring, and striving to understand the universe and our place within it. Imagine for a moment that you are aboard a spacecraft launched from Earth on a one-way mission to the heart of a cosmic void. As you journey further from the familiar glow of the Milky Way, the stars behind you dwindle to pinpricks of light, eventually vanishing altogether. You are surrounded by darkness, by a silence so profound that it seems to press in on you, a tangible manifestation of the void's immensity. What thoughts would run through your mind? What emotions would wash over you? Would you feel fear, awe, a sense of profound loneliness, or perhaps a strange sense of peace, of being at one with the universe in its most primal, most essential form? This thought experiment, however unsettling, highlights a fundamental truth about our relationship with the cosmos. We are voyagers in a universe of emptiness, adrift on an island of matter and energy, surrounded by the vast unknown. But we are not alone. We have each other. We have our curiosity. And we have the extraordinary capacity to explore, to question, and to find beauty and wonder even in the most unexpected of places. The cosmic voids may be vast, but so are the potential of the human spirit and our capacity for understanding. The journey into the void is a journey into ourselves, a reminder that even in the face of overwhelming emptiness, the spark of consciousness, the pursuit of knowledge, and the enduring power of hope can illuminate the darkest corners of the universe. Thank you for joining me on this journey through the terrifying voids that shape our universe. If you enjoyed this video, be sure to like, subscribe, and turn on notifications, because out there in the infinite dark, there's always more waiting to be discovered. Until next time, stay curious, stay brave, and never stop exploring.